Hello everyone, today I will explain Dijkstra algorithm to find shortest path. So here we have directed weighted graph. Here we have 9 vertices and edges. Each edge has own weight. So here we have to find from source is A, to other vertices the shortest path. For that we have to use table and Dijkstra algorithm. So to find shortest path we have formula. It's a minimum between previous weight and the weight plus previous label. I will explain what is previous label. So here from A to A we have short path is 0, so you have to define it as 0, and for other ones you have to define them as infinite. It's for checking, it's for compare from and here previous weight is infinite. And next one, from A we have direct arrow, direct path is from A to B and from A to H. So from A to B, here is our previous label, it's a 0. Let's define it as a square and the sign. Previous weight is infinite, so here we have to keep 0. And from A to B, its previous weight is infinite, and the actual weight is 3, and previous label is 0, so previous label plus 3, it's 3, and 3 is less than infinite, so we have to write here 3. From A to C we don't have direct path, so we have to keep infinite, 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 infinite. To G we also don't have path, so we have to keep infinite, but for H we have path, and here is the weight is 4. 4 plus 0 is 4. 4 is less than infinite, so we have to write here is 4. To L we have to keep infinite. So okay, next one. Let's check from the B, and here our previous label gonna be 3. From B we have a path to C, so here we have to keep 3, 0, 3, and from B to C, so actually weight is 7, but previous weight is previous label is 3, so 3 plus 7 is 10. 10 is less than infinite, so here we have to write 10. From B to D we don't have direct path, so we have to keep here infinite. From B to E we have path, its actual weight is 3, previous label is 10. Previous label is 3. 3 plus 3 is 6. 6 less than infinite, so here we have to write 6. To F we don't have path. To G we don't have path. For H we don't have path, so we have to keep previous one is 4. To L we also don't have path. So let's continue with next one. Next one is H, but from H we don't have any direct path to any vertices, so we have to skip it. So okay, next one is C. Let's define C is as previous label. From C we have path to D and E. So here we have to keep 0, here we have to keep 3, Okay, from C to D, it's actually weight is 4. But previous one is 10. 10 plus 4 is 14. 14 is less than infinite, so here we have to write 14. From C to E you have pass. Actually weight is 6, but previous label is 10. Previous weight 10 plus 6 is 16. But 16 is more than 6, so minimum one is 6. Here we have to keep 6. To F we don't have pass. To G you also don't have pass. To H we don't have pass, so we have to keep 4. To L we don't have pass. Okay, next one, let's keep E as previous. So we have to check. From E we have only one pass, it's to F. 3. We have to keep 10. Here we have to keep 14. We have to keep 6. Okay, from E to F the pass, the weight is 2. 2 plus previous one 6 is 8. 8 is less than infinite, so here we have to write 8. To G we don't have pass, we have to keep infinite. Here 4, here infinite. Okay, now we have to define from D. From D we have only one direct pass, it's from D to E, its weight is 5. Okay, 0, 3, here is 10, here 14. Okay, from D to E the weight is 5. Previous one is 4. Previous one is 14. 14 plus 5 is 19, but 19 is more than 6, so we have to find the minimum one. The minimum one is 6. Okay, to F we don't have pass, so we have to keep here 8, infinite, 4, infinite. Next one is F. Next one is F. So here we have to keep previous label as F. 0, 3, 10, 14, 6, 8. From F we have direct pass from F to L and from F to G. Okay, from F to G weight is 1, previous one is 8. 8 plus 1 is 9. 9 is less than infinite, so here we have to write 9. Okay, next one, from F to L weight is 3, previous one is 8. 8 plus 3, it's 11. 11 is less than infinite, so here we have to write 11. Okay, so next let's check from G. From G we have 3 directions. It's from G to H, from G to A, from G to L. Okay, from G to A it's actually weight is 5, and but previous one is 9. 5 plus 9 is 14. 14 is more than 0, so we have to here we keep 0. To B we don't have pass. To C we don't have pass. For D we don't have pass. For E we don't have pass. For F we don't have pass. For G it's have to keep 9. For H it's actually weight is 7. 7 plus 9 is 16. 16 is more than 4, so you have to write 4. To L, 4 plus 9 is 13. 13 is more than 11, so here we have to write 11. Okay, next one, it's L. From L to B we have pass. It's only one pass. Its weight is 2, but the shortest pass to B is it's 3. We already find it, so we have to skip it because it's already understandable that it's not the shortest pass. Let me skip it faster. Okay, so here we find our shortest path to each vertex. It's from A to A it's 0, from A to B it's 3, from A to C it's 10, from A to D it's 14, from A to E it's 6, from A to F it's 8, from A to G it's 9, from A to H it's 4, from A to L it's 11. So thank you for your attention. The last row is our last shortest path to each vertex from source A. Thank you.